Hello to everyone. Welcome back to our channel. I'm continuing my question solutions for University General Physics students. I'm here with a new one and a great question. If you'd like, let's get started on the solution without delay. A woman is reported to have fallen 60 meters from the 17th floor of a building, landing on a metal ventilator box, which she crushed to a depth of 20 meters. She suffered only minor injuries. Okay. First of all, let's visualize the given event to better analyze and solve the problem. It is mentioned that there is a woman on the balcony on the 17th floor of a building. Let's draw the building like this. It is mentioned there is a ventilator unit here, ventilator box here. It's mentioned on the 17th floor, a balcony or window, and a woman inside. And it is stated that this woman fell down. We can draw this as follows. We can draw the event that took place in this way. The fall height is also 60 meters. And the information provided indicates that the crush injury to the ventilator box was 20 meters due to the woman's fall. In summary, this is what happened. To better solve our problem, we can use the X and Y coordinate system and understand that the movement here is in the Y direction. Additionally, motion is movement in one dimension. Following our analysis and notes, we can now answer the questions. Here's one additional information as well, neglecting air resistance. Okay, first question. Calculate the speed of the woman just before she collided with the ventilator. The speed of the woman immediately before she hit the ventilator box is being asked. If you like, let's call the speed just before this collision V woman. This speed value is being requested from us. We will proceed with the answer as follows. The woman has no initial velocity because she fell from the balcony. Free fall occurs. So, we can say that the initial velocity is 0. I know the woman's initial speed and I'm being asked for her final speed. Therefore, we can solve it using the motion formulas. Is there any information in the provided details about the duration of the movement? Unfortunately, no. Additionally, since the motion here is in the vertical direction, there is also downward gravitational acceleration. Although this information is not provided in the question, we know it. Based on this information, I will use the speed formula to calculate the woman's speed immediately before she hit the box. The speed equation I will use is as follows. The square of the final velocity in the y direction equals the square of the initial velocity in the y direction plus 2 times acceleration in the y direction times delta y, or instead of delta y, we can also say height difference. This is the formula we can use. If we substitute the numerical values we know for the parameters we expressed in the equation, we can easily find the woman's speed before she hit the ventilator box. The square of the woman's final speed before impact is equal 0 squared plus 2 times vertical acceleration in the y direction, 9.831. The height difference is times 60 minus 20. When we write the numerical data, this equation appears. And if you notice, there is only one unknown in the equation, so it can be easily solved. The square of the woman's speed before impact equals 784.8. Now I'm taking the square root on both sides. The woman's speed equals, we find it to be 28.01 meters per second. So, just before hitting the ventilator box, this woman who fell from the 17th floor reaches a speed of 28.01 meters per second. This way, we are finding our first answer and continuing. Let's move on to the second question about the incident without delay. The second question is as follows. Her average acceleration while in contact with the box. Before continuing, we are clearing our page. Here we are asked for the average acceleration value affecting the woman during the collision. Since the acceleration during the collision is being asked here, we should focus on the ventilator box and the collision. I can describe the situation as follows. Woman is here, and there is deformation in this way. Here, a force acts in the opposite direction to the woman's movement, preventing her from hitting the ground. thus applying a restrictive acceleration on the woman. The woman is stopping before hit the ground. This acceleration is being questioned. We calculated the woman's initial speed when she hit the box, so we know it. We can call the velocity at which the woman fell at the final point v woman's final velocity, and we know these values. We also know the final velocity, because the woman is falling and stops before hitting the ground. Stopping means the woman's velocity is 0 at the final position. The acceleration affecting the woman in the incident that occurred here is being questioned. I will use the appropriate one from the equations of motion for the solution again. I have two options for a solution. I will choose based on the data I have. One of my options is a motion formula that includes time. However, we do not have time information. In this case, I will use the timeless velocity formula. I will use the formula as follows. The square of the final velocity in the y direction equals the square of the initial velocity on the y-axis plus 2 times acceleration in the y direction times delta y, or instead of delta y, we can also say height difference. So how much is the height difference? We know this. We have been given the value of 20 meters. In this case, I can easily calculate the acceleration using the data I have. Final velocity is 0, so 0 squared equals initial velocity is 28.01, so 28.01 squared plus 2 times acceleration times 20. If you notice, there is only one unknown in the equation, so it can be easily solved. The acceleration value affecting the woman is 19.6 meters per second squared. So, the acceleration value acting on the woman during the accident was 19.6 meters per second squared. In addition, the direction of the acceleration is opposite to the woman's direction of motion. Thus, we have found the answer to the second question asked of us to be 19.01 meters per second squared. Now we will answer the last question asked of us. Final question is as follows: the time it took to crush to the box. I cleared the page for the solution, so let's get started. We will find the crush time here. We must focus on the collision again to solve the problem. Let's take a closer look at the moment of collision and redraw it if you like. We had calculated the pre-collision velocity, so we know this. Its value is 28.01 meters per second. We also found the acceleration value during the collision, and the value was 19.6 meters per second squared. We also know the final velocity after the accident. The final velocity is 0 meters per second because the woman is stopping still. The height of the ventilator box was also 20 meters. The duration of the accident is being asked. To find the time value, I need to use the formula that includes time from the motion formulas. The equation of motion I will use is as follows. Final velocity is equal initial velocity plus or minus acceleration times time. If I adjust this formula according to this event, the woman's final velocity is equal the woman's initial velocity minus acceleration in the y direction times crush time. Here, final velocity is 0 equals 28.01 because the woman's initial velocity is this, minus 19.6. Times crush time. In this equation, we can easily find the unknown time value. If we perform the necessary calculations, the crush time value is calculated as 1.43 seconds. Here, it took 1.43 seconds for the boxes to collapse after the woman collided with the ventilator box. Alright, this way, we have found the answer to the last question asked of us and completed the solution. That's all for today. I hope this solution helps you. If you have any questions, feel free to leave them in the comments. Rest assured, I'll respond when I'm available. Thank you so much for watching. Don't forget to subscribe and like our video for more content. Take care and goodbye.